where it says f of x is x squared plus 5x plus p. P is a number between -3 and 8. It's also, they're telling us it's a real number, and they're telling us p belongs to z. Real number, we'll just remind you, it's all the numbers, decimals plus minus, and z, of course, it's all the whole numbers minus plus. So when they're telling us that p is a number between -3 and 8, it can be -3, -2, -1, 0, and so forth. The question is asking us, find the value of p for which x plus 3 is a factor. So when they tell us x plus 3 is a factor, that means that -3 is a root. I know that because if I equate x plus 3 to 0 and rearrange, I'll get that x equals -3. That means it's a root. That means if you sub that in, you will get 0. So a root is where it hits the x-axis. So we'll do that. We'll sub that for the x. So we get -3 to be squared plus 5 times -3 plus p. That has to give us 0 because -3 is a root. -3 squared is 9. -5 times -3 is -15. Plus p equals 0. So p, if we rearrange, we get that p equals 6. 6 is in the interval. It's between -3 and 8. Therefore, that's our answer. For the second part of the question, they're saying find p, where f of x will have roots which differ by 3. That means if one root is a, the other root is a plus 3 or a minus 3. It doesn't really matter. So they're telling us, we know that from the equation, x squared plus 5x plus p, we know that 5 is minus the sum of the roots. So if we add the roots, that has to give us -5 because it's minus the sum. 5 is this minus the sum, so we have to put the minus there. Add this, rearrange, take 3 to the other side by taking 3 from both sides. Divide by 2 both sides. We get that a has to be -4, sub it in. So a plus 3 will be -4 plus 3, which will give us -1. So that means one root is -4 and the other root is -1. Now we know that p is the product of the roots. So we just multiply these two roots and that gives us 4. So p has to be 4. That's our final answer there. Function will not cross the x-axis. The function that there is given is a smiley face function because the coefficient of x squared is positive. It's just 1. Therefore, we know that in order for this not to cross, we need them to be above the line. In other words, no roots. In order for it to have no roots, we know that the condition for that is b squared minus 4ac, the discriminant. That means that's the part that's under the square root of the roots, has to be smaller than 0. So we'll do that. B squared, so reminding you, our b is 5. So 5 squared minus 4 times 1 times p, because we don't know p in this case, has to be smaller than 0. That's 25 minus 4p has to be smaller than 0. Rearrange, so we get 25 has to be smaller than 4p. Divide by 4 both sides, so p has to be bigger than 25 over 4. So p has to be bigger than 6.25. Remember at the beginning of the question, they said that p has to be a whole number. So p can be 7 or can be 8. These are the options for p. They say find 2 values for p. So we did find 2 values. P can be 7 or p can be 8. Now for the last part of this question. Find the range of values. Remember, this is now going to be a range between something and something for x for which 2x plus 5 minus 1 has to be smaller or equal than 0. To solve this, we're going to square both sides. So first of all, we're going to bring -1. We're adding 1 to both sides. So we'll have 2x plus 5 has to be smaller or equal than 1. At this stage, I'll square both sides to get rid of the absolute value. So we get 2x plus 5 to be squared has to be smaller or 1 squared. Squared is 1. Multiply out, so we get 4x squared plus 20x plus 25 has to be smaller or equal than 1. Rearrange again, 4x squared plus 20x plus 24 has to be smaller or equal than 0. We'll divide everything by 4 just to make the numbers nice and small. So x squared plus 5x plus 6 has to be smaller or equal than 0. The first thing we're going to do, remember, if we're solving inequalities that are power of 2 or up, you have to solve it graphically. Therefore, in this case, first of all, we're going to find the roots in order to be able to graph it easily. So the factorizing of this is 2 times 3. 2 times 3 gives 6, 2 plus 3 gives 5. So I know that my factors are x plus 2 and x plus 3. Whoever doesn't like doing factorizing can do the minus b formula. Solve for this. We're multiplying two numbers to get 0. So one of them has to be 0. If x plus 2 is 0, it means x is minus 2. If x plus 3 is 0, it means x has to be minus 3. I have my two roots. I'm going to draw my x-axis. This graph, the coefficient is positive. So I can see the coefficient here of x squared is positive. It's the number 1. Therefore, it's a smiley face graph. I'm going to graph it. I'm putting my two roots, minus 3 there, minus 2 there. And now I'm going back to my question. The question is asking me, when is it smaller than 0? Smaller than 0, it's below the line. So I marked below the line. And then I have to mark the x's that are relevant, that give me this line below the line. And they're the x's that are between minus 2 and 3. So for final answer, I put my x between the minus 2 and the minus 3. And I open the mouth of the inequality to the right, because on the right-hand side, the numbers are always bigger than the left-hand side. I go back to my question to see, do we allow equal? The question allows equal. So I'm allowing equal on both sides. That is my final answer, which means that when x is between minus 2 and minus 3, we have our solution. Find two values, complex numbers, for which satisfy these equations. So this is simultaneous equations. If you look at the first equation, it only has Z1 in it. The second equation has two, Z1 and Z2. So I'm going to go to the first equation of Z1 and figure out what Z1 is. So IZ1. Okay, the first thing I need to do is get rid of my I in front of Z1. So I'm going to divide everything by I. So when I divide everything by I, on the left-hand side, I cancels, and I'm left with Z1 equals minus 4 plus 3i over I. This is a dividing sum in complex numbers, and the way to get rid of the I on the bottom is multiply top and bottom by the conjugate of the bottom. The conjugate of the bottom is minus I, so I'm multiplying top and bottom by minus I. On the bottom, on the denominator, I'll be getting minus I times I is minus I squared. My I squared is minus 1, minus 1 is just plus 1. So the bottom I've cancelled and I have only the number 1 there. Now I'm multiplying the top. Minus 4 by minus I is 4i. 3i by minus I is minus 3i squared. Now I need to fix this. So I squared is minus 1. So I have minus 1 times minus 1 is plus 3, minus 3 times minus 1 is plus 3. So I'm just writing the real number first, plus 4i, and that is my answer. So Z1 is 3 plus 4i. I found one of the variables that is missing, one of the numbers. Now the next thing, I'm going to sub it into the next equation and figure it out. So I have 3 times Z1, so 3 times 3 plus 4i minus Z2 has to be equal to 11 plus 17i. I'm going to rearrange. I'm going to add Z2 to both sides, and I'm going to take the one numbers on the right to the left. So I'm going to write 3 times 3 plus 4i minus 11 minus 17i equals Z2. Multiply out on the left-hand side. So 3 times 3 is 9, plus 3 times 4i is 12i, minus 11 minus 17i equals Z2. Add the real to the real, the imaginary to the imaginary. So 9 take 11 is minus 2. 12i take 17i is minus 5i. Okay, so part B gives us two numbers, 3 plus 2i, 5 minus I, and they're telling us these are the first two terms of a geometric sequence. Geometric sequence is a sequence that has the same ratio. That means if I divide any two consecutive terms, that means it's 2 to 1 or 3 to 2 and so forth, I get the same ratio. They're saying find R, that means find the ratio, and we find that by dividing one to another. Now, since these are the consecutive, I do 5 minus I to divide to 3 plus 2i. They want the answer in the form of a plus bi. That means we have to multiply, do the division. That means we multiply top and bottom by the conjugate of the bottom. Do that, multiply top and bottom by the conjugate of the bottom. Conjugate of the bottom, I'm reminding you, just means the same number on the bottom with change the I, the imaginary part, to a negative. If it's plus, you make minus. If it's minus, you make plus. We have to multiply this. On the bottom, this is the difference of two squares. So all I have to know that on the bottom, I'm going to get 3 squared minus 2i squared. I don't have to do this. If you know to do it faster, you can do that. So 3 squared is 9. And 2i squared is 4i squared. I squared is minus 1. So I get minus minus is plus. It's a plus 4. So on the bottom, we have 13. Now on the top, 5 by 3 is 15. Minus i by 3 is minus 3i. Minus 2i by 5 is minus 10i. Minus 2i by minus I is plus. Minus by minus is plus 2i squared. Now we have to fix this I squared guy. That's minus 1. So we get 15 minus 2 is 13. And minus 3i minus 10i is minus 13i. I'll write that here. This looks quite good, except that they say in the form a plus bi, so they don't want this dividing line. So I'm going to split my fraction. It's 13 over 13 minus 13i over 13. 13 to divide to 13 is 1, so it's 1 minus 1i. And this is the final answer for this part. Okay, for the next part, they're saying use the Moivre theorem. I'm reminding you the Moivre theorem is on page 20 in the logbook. And they're saying to find T9. So first of all, what is T9? Before any de Moivre theorem, T9 from the formula in the logbook on page 22, we know it's A multiplied by R to the power of n minus 1, which is 9 minus 1 in our case. A is the first term, so the first term is 3 plus 2i multiplied by the ratio, which we found 2 seconds ago. That's R to the power of 8. They're telling us use the Moivre theorem. So why are they telling us use the Moivre theorem? Because we need to figure out what 1 minus 1i to the power of 8 is. And if we don't use the Moivre theorem, we'll have to multiply this bracket by itself 8 times. They're telling us have to use the Moivre theorem. Reminding how we use the Moivre theorem. For the Moivre theorem, we have to find what is the theta, what is the angle at this point, and what is the ratio, the radius that this point makes in the graph. So I'm going to show you how we do it. First thing we do, we graph that point. So 1 and 1 minus I. So on our real axis is the number 1. On our imaginary axis, we have minus 1. So the point is here on the, well, this is kind of not very amazing the way I wrote it. Fix that better. So let's say that's minus I. This is just to illustrate where it is. It doesn't really matter to be exact. And when I'm looking at this, I'm reminding you what the Moivre says. This line here is the radius of the circle that this guy is on, and I need to calculate that. I am looking at this triangle here, and I know that this length here is 1, and this length here is 1. So to get this, I'll do Pythagoras, and it's 1 squared plus 1 squared square root, which means the square root of 2. That is the radius of this. That's the R for the formula. You don't have to think about it like Pythagoras if you don't want. You can just think about it. It's called the modulus. So the modulus is R, the modulus of this number. The modulus is always the real part plus squared plus the imaginary squared without the I, without the minuses. And it's the same thing like what I wrote here. The next part you have to find is what's the theta. And I'm reminding you, theta is the angle that the point makes with the positive side of the x-axis. So this is what we're looking for. But we will actually use the triangle that we created here to find the theta. So theta, I'm going to find this first. Let's call it alpha. And whatever that will be, I will take it away from 360, and that will give me the angle that I'm actually looking for. So it's always going to be tan minus 1 of the 1 over 1, which gives us 45 degrees. So I know that this angle here is 45 degrees, but the angle that we're looking is 360 minus 45 degrees. That gives me 315 degrees. Now you can do it in radians or you can do it in degrees, unless the question tells you otherwise. This question doesn't tell you how to do it, so you can do it any way you like. So now I'm going to put it into my formula. The radius is square root of 2 cos 315 plus I sine 315. All of this, we have to use the Moivre. So it says do to the power of 8. Reminding you what the Moivre says. It says take the radius and make him to the power of 8, and take each angle and multiply it by 8. Okay, so now you take your calculator, you calculate 8 times 15, 8 times 315, and you calculate cos of that. That gives you 1. You do the same sine of 8 times 15, and that gives you 0. So and the square root of 8, square root of 2 to the power of 8 gives you 16. So the final answer is 16 times 1 plus 0i. And in this case, it's 16 because just 16 times 1 is 16. And that's the final answer. If the question tells you write the answer in the form of a plus bi, you'll have to do that. But now we're not finished the question. We go back to our question. And we still have to, so this was 16. So now we have to still multiply that by 3 plus 2i. So 16 times 3 is 400, is 48, plus 2 times 16 is 32 i's. And this is your final answer here. Question number 3 gives you two functions, 6x minus 5 and x plus 5 over 6. And they're asking you, investigate if f of g is the same like g of f. This is a composite question, composite function. They're giving us both, but they're asking us to composite both ways different. I'm just reminding you how we do composite questions. We start for the inside guy, that's the first one, and he goes into f. So for the left-hand side, when they want f of g, it means you take g, which is x plus 5 over 6, and you sub it in 4x in f. So you do 6 times, instead of x, we're going to write x plus 5 over 6 minus 5. So remember again, we always start from the right-hand side. He's the first guy we're doing, and then he goes into f. So x plus 5 over 6, he's the x now of f, so you sub it in. To solve this, we multiply 6 times x plus 5 over 6, 6 and 6 make 1, so it's x plus 5 take 5, and that gives x. We have to do the same on the right-hand side, but this time f of x goes into g, so f of x is 6 minus this, so instead of the x, we write 6x minus 5, that's our f, that's instead of the x, plus 5 over 6. 6x minus 5 plus 5 over 6. 5 and 5 make 0. 6x divided to 6 is 1. 6 divided to 6 is 1, so we're left with an x. So in this case, conclusion, yes, it is the same. If both in this case, it's not always the same, but in this specific case, it is the same. Next part of the question, they're asking us the real variable x, y, and x are real, and they're telling us here's the connection between them, y equals 5x squared. They're telling us this equation can be written with logs. Now, if you look at this question, the log is base 5, so we will have to do our calculations with base 5, find the value of a and b in this opening. So in order to do that, we'll just inflict log on both sides. The log that we're going to put on both sides is log base 5. So we just put log base 5 of y equals log base 5 of 5x squared. This is correct because if the numbers are the same, y is equal to 5x squared. So even if we put log on both sides, because we're doing it to both sides of the equation, it is still correct. On the left-hand side, I'm doing nothing because I can see it matches the answer that they want. And on the right-hand side, I'm going to use the log rules. Log says if you have multiplication, you can split it to log plus log. So that's log base 5 of 5 plus log base 5 of x squared. And this is page 21 in the logbook. The first rule of log says if you have multiplication, you can split it to adding. So I can see here log 5 of 5. I can take my calculator if I don't know and calculate it. It is 1. So that's 1. So already I found my a. My a is 1 because that matches the a here. And then log 5 of x squared, I can see that they only have x, so I have to get rid of the number 2 here on the top. This has to go. But if I look at the third rule of the log in the logbook, I can see that 2, you can bring it forward if you have a power that you don't want. So it can be 2 log 5 of x. So at this stage, this is now in the format that they ask us. So that means that b is 2. So we found our a and our b. So for the next part, they're saying hence or otherwise. Usually when they say hence, we do the hence. That means use the result that you got, find the real values of y for which log 5y equals this spiel here on the right. So I'm going to take my results from before, and I know that 1 plus 2 log 5 of x, this is the result that we got, is equal to log 5 of y. So I'm subbing it in, equals 2 plus log 5 of 126 over 25x minus 1. From here, I need to figure out first the x. Once I find the x, I'll figure out what the y is. So I know that 1 is log 5 of 5. And here I'm going to put my 2 inside, so it becomes x squared equals 2 is log 5 of 25. Okay, log and log makes log of multiplication. So I get 5x squared. And log plus log is log of the multiplication. Log is equal to log. The base is the same base. Therefore, the inside has to be equal to the inside. So I continue from here without the word log. 5x squared equals, and I'm multiplying out 25 times 126x over 25 is 126x. And 25 times minus 1 is 25. Minus is there. Once I reach this, I can rearrange. So 5x squared minus 126x plus 25 equals 0. I'll do my minus b formula. So it's minus b, so it's 126 plus minus the square root 126 squared minus 4 times our a and our c all over 2 times our a. You'll have to solve these two. And the square root is 124, so we get 126 plus minus. So I'll just do the plus on the top. 124 over 10. And 126 minus 124 over 10. Sorry, this is 124, it's not 125. 126 and 124 makes 250. To divide to 10 is 25. And the other answer is 2 over 10, which is 0.2. Or a fifth, if you want to write it as a fifth. It's also a fifth. These are the x's. So I need to sub them in now to get my y. So I know that y equals 5x squared, which means 5 times 25 squared. 25 squared is 625 times 5, whatever that gives. So the calculator gives 3125, and the other answer is 5 times 1/5 squared, and that gives 1/5 when you do that in the calculator, or 0.2. So these are the two values of y. Go back to our question just to see that these values are logical, and we put them in here, and we see, first of all, log y positive, no problem. 3125 is positive and 0.2 is positive. So these are the answers. The question says real values. They are real values. Values is plural. We got 2 answers. So we're happy with our result. Okay, question number 4 is giving us a diagram of 2 functions, f and g. F is the it's the cubic function, and g is just the straight line that we can see here. First part of the question is telling us, given that f tag of 3 is minus 12, that means f tag, so I already know I will need to differentiate here. That's the first thing I'll have to do. It says of 3 a 3, so that means you'll have to sub that in. And then it says it's equal to minus 12. So I'm going to continue reading the question. Show that k is minus 9. So we know that that will give us the result. Let's do it. So the first thing we're going to do is f tag. That means differentiate. Remember, x cubed becomes 3x squared. 3 comes forward, plus 2 comes forward now, so 2kx, plus power of 1, so that means just 15, and the differentiation of 8 is 0. They're telling us the differentiation f tag at the number 3, when x is 3, is equal to minus 12. So I will sub in 3 and then make it equal to minus 12. So 3 times 3 squared plus 2k times 3 plus 15 has to be equal to minus 12. 3 times 3 is 9, times 3 is 27, plus 6k plus 15 equals minus 12. 27 and 15 is 42. Rearrange. Divide by 6 both sides. And they said show that k equals minus 9. So we show that. And so we get k equals minus 9.